All right, here we're looking at section 9.7. And our learning targets for today, we're going to use trig identities to evaluate trig functions and simplify some trig expressions. And then we're going to verify some of these trig identities. So these identities that we're about to look at, you need to put somewhere in your notebook to reference often. You will use them a lot. You do not have to memorize them. You can use them on the tests. So make sure you put them in a place where you know where to find them. So here's our first couple of identities that we're really looking at. So remember our unit circle, and we have this angle theta, and I know that this point would be x comma y. Well, I know cosine is my x and sine is my y. So dealing with this triangle, I end up with x squared plus y squared equals 1. So then I can change that, right? Substitute. So cosine squared plus sine squared equals 1. This is really my trigonometric identity. We're going to be looking at some of these. This is just kind of where it comes from. So here are the real big identities that you absolutely need to know. So make sure these get put somewhere where you can find them easily. So of course we have our reciprocal identities, knowing that cosecant is the inverse or the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. We also need to know that tangent is the same as sine over cosine, which means that cotangent is cosine over sine. Then we've got some Pythagorean identities, right, where sine squared plus cosine squared equals 1. I also know that 1 plus tangent squared equals secant squared, and then 1 plus cotangent squared equals cosecant squared. Cofunction identities, these we use sometimes. So knowing that if I have that horizontal shift, that horizontal translation for sine, I end up with cosine. And same thing here and same thing with tangent, right? Just knowing that if I have that shift, I get the other one. So then I also have my negative angle identities, where the sine of a negative angle equals the negative sine of that angle. Cosine of a negative theta equals just positive cosine of theta. And the tangent of negative theta equals negative tangent of theta. So these are the first group that we're going to really look at. So make sure that you copy all of these down in a way that you can use them. So here we go. Given that sine of theta equals 4 over 5, and that we're looking at pi over 2 to pi, which means we're looking in our second quadrant, find the values of the other 5 trig functions. Okay, so I'm going to show you how to do this 2 different ways. So the first way is I first have to find that cosine of theta. So I'm going to be using my Pythagorean identity here. So I can substitute my 4/5 for sine squared, for sine, right? So I'm going to end up squaring that, subtract that from each side. So I end up with cosine squared equals 9 over 25. So then to find cosine, I go ahead and take the square root of both of those. So I end up with plus or minus 3 over 5. Since I'm in the second quadrant, I know that my cosine is going to be negative. So now I have all of the values that I need to look at. Okay, so I know tangent is sine divided by cosine, so I go ahead and I take my sine and divide it by cosine. Cotangent is cosine divided by sine. Cosecant is 1 divided by sine. Secant is 1 divided by cosine. And there's all of my trig functions. Okay, so that's one way I can look at this. So now let's look at a different way that makes my life a little bit easier. Okay, so I know that I'm dealing with things in the second quadrant, so it's going to be up here. All right, so I'm going to go ahead and draw my triangle over here, and here's my angle theta. Okay, and I was told that my sine of theta equals 4/5. So I know sine of theta equals 4 over 5. Well, I know from my just general trig functions that sine is the opposite over the hypotenuse in this triangle. So the opposite over the hypotenuse. So now I see I still am dealing with a triangle, and I'm trying to find this side right here. Okay, so in order to find this, I can go and use the Pythagorean theorem, which gives me 5 squared equals 4 squared plus x squared, right? 25 equals 16 plus x squared. 9 equals x squared, so x equals 3. And here I know I'm going to be on the negative side because, again, just based on where my triangle is, this x is going to be a negative 3. So now, using this triangle, I can find all of my trig functions, right? Because I know tangent is the opposite over the adjacent. So tangent of theta would be negative 4 over 3, right? So I know that cosecant, because cosecant's the inverse of sine, would be my hypotenuse divided by my opposite side. So here I'm getting the same answers that I did down here. I just did it a little differently. So either way is fine. You can do either way, whichever way works best for your brain. So now we're going to be simplifying some stuff. So here I see I'm going to be using one of those identities that I wrote down, right? Because I see something that looks pretty similar. So I have my tangent of pi over 2 minus theta times the sine of theta equals cotangent times sine, right? This is my cofunction identity, right? So if we go back to our identities, I know that tangent of pi over 2 minus theta is the same thing as cotangent. So I can rewrite this as cotangent times sine. So I know also now that cotangent is the same thing as cosine divided by sine. So now I can just kind of simplify, because when I multiply this out, I end up with sine divided by sine, which gives me 1. So I end up with cosine of theta. So that's completely simplified. So when we're simplifying using these trig identities, we always want to figure out, what do I have and what am I trying to get towards? We generally always want to get everything written in terms of sine and cosine first, just to simplify things. So that's always going to be your first goal, is how can I use these identities to get things written in only sine and cosine. So now let's look at part B. I've got secant of theta times tangent squared theta plus secant theta. Okay, so the first thing I want to do is I want to use my Pythagorean identity to get rid of my tangent squared, because I know tangent squared equals secant squared minus 1. So I can substitute that in. So now I can go ahead and distribute this secant theta. So I've got secant cubed minus secant plus secant. So these cancel out because I've got a negative and a positive. So now I'm left with secant cubed of theta. So now this is written in one trig function instead of using the multiple ones that we started with. Okay, so now here are a few for you to try. Definitely look down here and see, how would you simplify it, get it written in as few functions as you can. So now we're going to be verifying some identities. When you verify an identity, you really only want to work with one side of the equation at a time, because you already know what you're trying to get to. So here I'm looking at secant squared theta minus 1 divided by secant squared theta equals sine squared. So I know I'm going to try and get this left side to equal sine squared. Okay, so first thing I'm going to look is I'm dealing with fractions, so I can go ahead and write them as separate fractions. So I've got secant squared divided by secant squared minus 1 divided by secant squared. So it's just kind of unsimplifying this fraction. Well, now I know that secant squared divided by secant squared is 1, and so I'm left with this, and so I can make this whole thing squared. So now I know that this is the reciprocal identity, because 1 divided by secant is cosine. So now I have 1 minus cosine squared. Well, this I recognize from the Pythagorean identity is sine squared. So I can use the different identities to get me where I need to go. So here's another one that we're going to verify. So first thing I notice when I'm verifying this one is that I see a lot of different, I have secant, and then I have tangent, and then I have cosine, and I have sine. So I want to try and get things to be very similar on both sides. So I want to look at the left side first. So I'm going to go ahead and use my reciprocal identity, which turns the secant into 1 over cosine. Then I'm going to use the tangent identity, which is sine x over cosine x. Well, so now I see I have two fractions with common denominators, so I'm going to go ahead and add those fractions together. So I've got 1 plus sine x over cosine x. So I notice in my verifying, I need my denominator to have a 1 minus sine x in it. That's my eventual goal. So to get there, I multiply both the numerator and the denominator by my 1 minus sine x. And I can do that because this red piece right here is just 1, so I'm not mathematically really doing anything. Okay, so now I can simplify the numerator, which gives me 1 minus sine squared x, right? So if I was to multiply this out, and the denominator I just multiply. Well, so now I can simplify a little bit because I see that this numerator is my Pythagorean identity. So I end up with 1 minus sine squared x is the same thing as cosine squared x, so I can simplify, I can substitute that from my Pythagorean identity. Well, now I can simplify because I have a cosine in the numerator and a cosine in the denominator. So I end up with cosine divided by 1 minus sine of x, which was what my eventual goal was. So now here are some for you to try and verify. The biggest thing to look at when verifying is, what do I have and what am I trying to get to, and which identities will help me get there. So now looking back at our learning targets, we used some trig identities to evaluate trig functions and to simplify some trig expressions. Then we were verifying these trig identities. Now when we're looking at these verifications, they're a lot like geometric proofs of there's more than one way to get there. So you just have to mathematically explain how did you verify and what did you do. So now that we've looked at these learning targets, go and work on your homework for 9.7.